Hello, sunshines. I hope you guys are all doing well. So I'm going to try and make a video for today's lesson, but we're going to recap over the last couple things. So on Thursday? No. Maybe. On last week, you guys had an intro to angles and segments, so we're going to quickly go over that, and I'm just going to flip you around. So, a line segment is basically the space between two dots. Okay, so that is segment AB. And it's a little line above it, okay? Okay, a ray, we'll go ray CD, has a little arrow on it, and the arrow is always by the letter closest to the arrow, so that should be D. And its starting point is C, so it kind of looks like that. And then there's a line. A line continues on forever and ever in both directions. So E, F. And that's denoted by little lines over it with arrows on both sides, because that's what a line has. When we have an angle is basically made by two rays, segments, or lines. So I got this angle right here, and we're gonna make it two rays. We need to have 3 points. That's Piper saying hi. Let's go G, H, and I. Okay, so the angle is the space between here. We call it by 3 different points or just by the vertex. So the H is the vertex. If we name our angle, we have that symbol in front that means angle. And so this is angle GHI. Okay, it could also be called IHG or just angle H. Okay, all 3 of these are the same way to name this. Notice our vertex is in the middle when we name it with 3 points, and it's just the H, the vertex for this one. Okay, so there's that. You guys also learned about different types of angles. Okay, so let's see. I'm gonna swing you on over to here. So these 2 angles right here, these are called vertical angles. Vertical, okay? So they're basically formed by the 2 lines and they're crossing each other. Their measures are congruent, which means they are the same measure. So if this right here is 87 degrees, angles are measured in degrees, it's the amount of curvature. Angle 1 is also 87 degrees. Okay? Across from each other, same 2 lines, vertical angles, okay? We're gonna be using vertical angles a lot in the next unit. Okay, these 2 angles here, okay, they are right next to each other, so that means they're adjacent. Okay, they share a side and the same vertex. Okay, they also make a straight line. Okay, a straight line is exactly 180 degrees. A straight line essentially is called a linear pair because they make a line. And it also means they're supplementary. Supplementary adds to 180 degrees. Okay, linear pair makes a line. Okay, if you want to think about it this way, 2 90-degree angles make a straight line, so it has to be 180. Okay, the next one, this guy and this guy. So if we look here, these 2 angles are formed by the same 2 lines, so that means that angle 1 and angle 2 are vertical angles. Okay? Because they're formed the same. They're also the same measure. Okay? So in this case, angle 1 and this angle here have the same marking, so that means they're congruent. And they're gonna make a right angle, so each of these is 45 degrees. Because it splits that right angle in half. And this one's also 45. 45 plus 45 is 90, so that means angle 1 and angle 2 add to equal 90 degrees, which means they're complementary. Add to 90 degrees. Okay? So let's look at number 2. I kind of went out of order, but that's all right. So here, angle 1 and angle 2. They're going to be 2 of these, okay? They're going to be, well, they're next to each other and share the same vertex, so they're adjacent. And they also make a right angle, which is how many degrees? Yep, 90. So they're complementary. Okay? If we look at number 4, in number 4, angle 1 and 2, they're next to each other, so they have to be adjacent because they share a side in the vertex. But we don't know anything else about them. We don't know if this makes a right angle. We don't know anything else, so only adjacent. And the last one, number 6. These guys have 1, 2, I guess 3 of these types of angles. So 1 and 2, they're made by the same lines across from each other. So they are vertical. They do not share a side, so they cannot be adjacent. Let's see. If this guy's 90, that means that this one has to be 90, and this one as well. So if they're both 90 degrees, what do they add to equal? That's right, 180, so they're supplementary, which makes them a linear pair, because if we put them next to each other, they'd be a straight line. Okay, so that's the basis on angles. When we did parallel lines, what you have to know about parallel lines is anytime we have parallel lines, we're going to have exactly 2 angle measures, okay? Your angle relationship's either going to be congruent, which means they're the same size, same shape, or they're going to add to equal 180. So if we look at this problem here, okay, we have all these angles here. Now, 1 and 3, see how they're both acute? And they're also vertical angles, so they're going to be the same measure. So if 1 is 65 degrees, that means that 3 has to be 65 degrees, okay? And if we look at 1 and 2, well, they're adjacent, and they make a straight line, so these 2 have to add to equal 180. So if we take 180 and subtract the 65 from it, we get 115. So every obtuse angle in this whole little thing here is going to be 115 degrees, and every acute will be 65. Okay? Let's see, he's acute, so he's 65. He's 65. This one's 115 and 115. I apologize about my bad handwriting. Okay? The relationships have special names. So, corresponding means that they are in the same position on a different parallel line. So if I go to here, my corresponding angles. Okay, angles that lie in the same position. Oops, I should probably keep it this way. But on different lines. So 1 here corresponds to 5. They're both in the top left-hand corner. Okay, so I'm going to give them the same marking. 2 right here, he corresponds to 6. They're both in the top right-hand corner. Okay, same position, different parallel line. And notice they have the same type of angle. They're both acute. Now, 4 is going to correspond to which one? 7 or 8? Let's see, 4 is obtuse. It needs to go with the obtuse one. It's in the bottom right corner, so it needs to go to 8. And that means that angle 3 and angle 7 in this case are corresponding. Bottom left corner, bottom left corner. Okay? So there's corresponding angles, same position, different line. There are alternate interior angles. So alternate interior angles are inside the parallel lines, on opposite sides of the transversal. The transversal is just that line that's cutting through our parallel lines. So if I go here, here's my transversal, and here's my parallel line. Okay, so my alternate interior. So 3 is an interior angle. It's on the opposite side to the transversal, okay, at 6. So 3 and 6. These guys are the congruent ones. Okay, alternate interior. They're not going to be next to each other. They're going to be different lines, okay? And the other pair of alternate interior is going to be 4 and 5. Okay? Opposite sides of the transversal between the parallel lines, and they are congruent. So alternate interior is congruent as well. So they'd have the same measure. If this one was 100, that means that 4 would also be 100. And so that means that 3, okay, is going to be 180, take away 100 to get 80. And 6 would also be 80. So same two angle measures throughout the whole thing. Okay, alternate exterior is very similar, except for it'll be on the exterior of our parallel lines, or outside. So alternate exterior, outside parallel lines on opposite sides of the transversal, same angle measurement, so they're also congruent. Okay, so let's see, I'm gonna trace my parallel lines again. Well, that's interesting trace. Okay, outside, so angle 1 is outside. My transversal is right here, so the alternate exterior to 1 would be 8. And then we have 2, and he'll be with 7. Okay, and the only other one you'll have that is not congruent, that's supplementary, is consecutive interior angles. They're also referred to as consecutive interior angles, or same side interior angles. Okay, these guys are going to be a pair of angles. They will be supplementary, which means they add to equal 80, and they're inside the parallel lines on the same side of our transversal. So the measure of angle 3 plus the measure of angle 5 will equal 180. Okay, same here. The measure, that's what the M stands for, of angle 4 plus the measure of angle 6 will equal 180. So let's say angle 4 was 116 degrees. So 180 take away 116. That'll give us, oops, that's not right. 64 degrees. So the measure of angle 6 is 64 degrees. Okay, so I'll do 2 examples like that, and then I'm going to put some new information on here, and then I'll also tag where the new information starts. So we're going to do some 2 problems with algebra. Okay, so I'm going to flip you around, and this is just a different page in the packet. You guys can get the packet from one of the posts. I think it's Unit 5 packet. I posted it on there just in case you guys want to look at it, and work out a couple more problems if you like. The baby's sleeping. That's my nephew. All right, so if I look at number 1 on this coloring activity, which you guys are not going to do, okay, I've got these 2 angles. So I've got my parallel lines here. The angles are between the parallel lines. They're on opposite sides of the transversal. So they're alternate interior angles. Okay, and more importantly, I'm looking at their shape. So he is an acute angle, and this one's an acute angle. They're both acute, okay, and they're alternate interior, so that means their measures are congruent or the same. So what I can do is say that 14x minus 13 equals 8x plus 5. Because their measures are the same, I can set them equal to each other. Okay, and so let's see, I'll subtract the 8x, and I'll add the 13 over. So that cancels and that cancels. So 14x take away 8x, leaves me with 6x, equal sign comes down. And 5 plus 13 is 18, and then I'll just divide. So x should equal 18 divided by 6, which is 3. All right, if I look down here, there's an answer that's a 3. Okay, so let's do another one. We'll do the one right below it. So number 3 on here, I'm going to find the value of x. So I have the angle is right here, and the other angle is right here. Okay, so these 2 angles are between the parallel lines. They're on the same side of the transversal. And if we look at this, that same side interior. Okay, so this angle is acute and this angle is obtuse. Okay, so they're different types of angles. All right, if they're not the same type of angle, they're not going to be equal, but these two are different types, so they're going to add to equal 180 because they're supplementary. Because there's only 2 angle measures in a whole parallel lines and transversal. So what I'm going to do, I've got my 3x plus 5. I'm going to stack the other one. 7x minus 15. Oops, sorry, over here. And I'm going to add them together. So we've got 3x plus 7x is 10x. 5 minus 15 is a negative 10. And since they're supplementary, they're going to add to equal 180. So I'll solve for x. Add 10. So 10x equals 190. Then we divide by the 10 to get x equals 19. Okay, and if I look down here, there is a 19, so I know it's right. I could always plug it back in to see what this angle measure is and this one is, and if they add to equal 180, then I know it's right too. All right, so hopefully most of you guys got this. All right, the new stuff today, and I'll mark this down starting at 16 and a half. All right, we're gonna look at triangle properties. So in a triangle, they always have 3 angles, and there is one rule we have to learn or understand. All the angles of a triangle are gonna add to equal 180. If we were to take a triangle, let's see if I can take one. I'll just rip it off here. Yeah. I think I need some scissors. Eek. Little arts and crafts with Fowler. It's fine. So I've got this triangle here, and I'm gonna mark in all the angles, just so you guys can see them. All right, so you see my angles? Okay, so I'm gonna take this triangle, I'm gonna take all the angles off of it. And just rip them off. Okay, there we go. And then I'm gonna show you guys.